Plus 1 Chemistry Chapter 3 Classification of Elements. 1. Daubrunet's trait. Certain similar elements exist in groups of 3 elements called traits. Elements are arranged in order of increasing atomic mass, and the atomic mass of the middle elements is the arithmetic mean of the atomic weight of the other 2 elements in the trait. 2. Newland's law of octaves. Elements are arranged in the order of increasing atomic weight, and it was noticed that every 8th element had the properties similar to the first element. 3. Mendeleev's periodic law. The properties of the elements are a periodic function of their atomic weights. Merit Mendeleev's periodic table. 1. It was the first comprehensive classification of elements. 2. He corrected the wrong atomic weight of some elements and placed them in correct position in the periodic table. 3. He left vacant places for undiscovered elements and predicted some of their properties. Defects in the Mendeleev's periodic table. 1. Position of hydrogen is not justified. 2. Isotopes are placed in the same position in the table. 4. Modern periodic law. The physical and chemical properties of the elements are periodic functions of their atomic numbers. In modern periodic table, numbers of groups 18 and numbers of periods 7. 5. IUPAC nomenclature for elements with atomic number 100. Electronic configuration and types of S-block elements. Elements belonging to group 1 and 2. General electronic configuration varies from NS1 to NS2. Group 1 Alkali metals. NS1 outermost electronic configuration. Group 2 Alkaline earth metals. NS2 outermost electronic configuration. Alkali metals from +1 ion and alkaline earth metal form +2 ion. They are never found in pure state in nature, reason they are highly reactive. P-block elements. Elements belonging to group 13 to 18. General electronic configuration varies from NS2-NP1 to NS2-NP6 in each period. Group 13 boron family, NS2-NP1. Group 14 carbon family, NS2-NP2. Group 15 nitrogen family, NS2-NP3. Group 16 oxygen family, NS2-NP4. Group 17 halogen family, NS2-NP5. Group 18 noble gases, NS2-NP6. Non-metallic characters increases from left to right across a period. D orbital transition elements. Elements of group 3 to group 12. General electronic configuration is n-1 d raised to 1 to 10 ns 0 to 2, called as transition elements. All are metals. They form colored ions, exhibit variable oxidation state, paramagnetism, and are used as catalyst. F-block elements. 14 elements of lanthanoids, 14 elements of actinoids, outer electronic configuration. They are called inner transition elements. 7. Periodic trends in physical properties. 1. Atomic radius. It is distance between center of nucleus with outermost electron of an atom. Variation across the period. Atomic radii decrease with the increase in the atomic number in a period. For example, atomic radii decrease from Li to F in the second period. From left to right effective nuclear power towards outermost electron increases, which cause decrease in atomic size. Variation down the group. Atomic radii increase from top to bottom within a group of the periodic table. Down the group number of shell increases. Variation of atomic radii with atomic number. Among alkali metals and halogen shows in graph. Isoelectronic species. Atoms and ions having the same number of electrons are called isoelectronic species. All these contain 10 electrons. Among isoelectric species, species with highest atomic number will have smallest size. 2. Ionization enthalpy. It is defined as the energy required to remove an electron from the outermost shell of an isolated gaseous atom in its ground state. Factors affecting ionization enthalpy. The important factors which affect ionization enthalpy are A. Atomic size greater than atomic size or atomic radius. Smaller will be the ionization enthalpy. B. Nuclear charge. The value of ionization enthalpy increases with nuclear charge. Shielding effect. As the shielding effect increases, the electrons can easily be removed and so the ionization enthalpy decreases. D. Presence of half-filled or completely filled orbitals increases ionization enthalpy. Variation across the period. Ionization enthalpy increases from left to right. This is because of the decrease in atomic radius and increase in nuclear charge. Thus, alkali metals have the least IH and noble gas have the most. Variation down the group. IE decreased due to the increase in atomic radius and shielding effect. Thus, among alkali metals, lithium has the most IE and francium has the least. First ionization enthalpy of Be is greater than boron. This is because of greater penetration power of 2s orbital of Be compared to 2p orbital of B. First ionization enthalpy of N is greater than that of oxygen. This is because N has half-filled electronic configuration 1s2, 2s2, 2p3, which is more stable, so more energy is required to remove an electron. 3. Electrogain enthalpy. It is defined as the enthalpy change taking place when an isolated gaseous atom accepts an electron to form a monovalent gaseous anion. Larger the value of electron gain enthalpy, greater is the tendency of an atom to accept electron. Variation across the period tends to become more negative as we go from left to right, that is, increase across the period. Variation down the group become less negative on going down the group, that is, decrease down the group. Electron gain enthalpy of fluorine is less negative than chlorine. Why? This is because when an electron is added to fluorine, it enters into the smaller second shell due to the smaller size. The electron suffers more repulsion from the other electrons. But for chlorine, the incoming electron goes to the larger third shell, so the electronic repulsion is low and hence chlorine adds electron more easily than fluorine. 4. Electronegativity. Fluorine is the most electronegative element, defined as the tendency of an atom in a molecule to attract the shared pair of electrons towards itself. Greater the effective nuclear charge, greater is the electronegativity. Smaller the atomic radius, greater is the electronegativity. Variation across the period. Increases in moving from left to right. Variation down the group, decreases on moving down a group.